All right, in this video, we're going to talk about piecewise functions, and in particular, we're going to talk about writing piecewise functions. And we'll get into what that means, but we're going to do just a quick review of writing equations for lines, and then we'll see how this is tied into piecewise functions. Next video, we'll talk about taking a piecewise function and learning how to graph it, but today we're going to talk about graphing it, or going from the graph to the equation. So first things first, we have write the equations for the lines on the graph at the right. So I've got two lines here, a white one and a pink one. And what I'm going to do is I'm just going to label these A and B. And so I want to write the equation for these lines, and we'll just write each one separately. So let's start with A. I'm going to use y equals mx plus b. And I know my slope, if I look, it goes over 1, down 1, over 1, down 1, over 1, down 1. So my slope is going to be -1. -1. And then we put the x. And then the b is the y-intercept, which is up 1, so +1. So this would be our equation for line A, -1x plus 1. Sometimes you might see it as y equals -x plus 1. You don't have to necessarily write the 1 if you're multiplying by 1. And then for b, same idea, y equals mx plus b. Our slope is going to go up 1 over 2, up 1 over 2, up 1 over 2. And so my slope is going to be 1/2. And then my y-intercept is down here at -2. So plus -2, or you might say y equals 1/2 x minus 2. Same thing. All right, so just kind of review of writing equations of lines. If you're learning about piecewise functions, this should be a review for you. So next step, now I have a piecewise function. What a piecewise function is multiple graphs or multiple equations or curves, they're often called. And curves doesn't mean that they necessarily have to be curvy. It just means it could be a straight line, it could be a parabola, something like that. But two or more curves on a graph where they're broken up and they're defined for certain sections. So let's get into this. If you notice, these are basically the exact same graphs as what we used before. So this one we called A, and this one we called B. The white one was A, pink was B. And so what we're going to do is we're going to write a piecewise function using these two. And I'm going to just refresh our memory. A was -x plus 1. And B was y equals 1/2 x minus 2. And so what I want you to see here is that A and B are pretty much, they're broken up right at the y-axis. So I'm going to get a vertical line here to kind of drag across. Oops, that's not what I wanted. Let's try that again. There we go. So I'm going to get this vertical line here to drag across. And what I want you to notice is that the pink one keeps going. It's pink all the way on the left of the y-axis until we get to the y-axis, and then the white line takes over. And so this is a piecewise function where the graph does one thing until you get to a point, and then there's basically a new graph that starts. And here would be going from graph B to graph A. So we're going to write a piecewise function. To do that, we start by writing f of x. And if you recall from previous math classes, f of x is often treated like y. Now, mathematicians don't like us saying that because f of x means it's a function of x. But oftentimes teachers will say something like, "Well, just treat it like y," and that's what we're going to kind of do here. And so we're going to write these two equations down. We're going to write, or these two linear equations down, yeah. -x plus 1, and then 1/2 x minus 2. All right, so we're halfway done with our piecewise function. Then what we need to do is we need to say, where do these two graphs exist? So I'm going to put a semicolon, and then I'm going to look at the graph and figure out where are these graphs happening. So the pink one is happening over on the left of the y-axis. The white is happening on the right of the y-axis. So how do we write that? What we do is we say if it's left of the x-axis, excuse me, the y-axis, x-axis. So for B, that graph, it is when x is less than 0. It's on the left of the y-axis. For the white one, it is when x is greater than 0. That's when it's to the right of the y-axis. That's when the x's are positive, 1, 2, 3, 4, and so on over on the right. Now there is one small mistake, and it's one thing that we do need to talk about still with this, is what's happening at 0. Which graph, the pink or the white, is happening at 0? So if we look at these two, there's one thing that tells me I know it's a certain graph that is defined at 0. And what it is this filled in circle. So the pink graph is defined at 0, whereas the white graph goes all the way up to 0, but it doesn't include 0. If it's an open circle, that means it does not include 0. If it's a closed circle, it does include that one. So for the B graph, we need to do less than or equal to. So we're going to put that less than or equal to sign there. This means closed circle. Maybe fill it in. And this one means open circle. Okay. So let's do one that's a little bit more tricky than that. So I've got a piecewise function here with 3 different parts to it. So let's do this. We'll call this one A. We'll call the yellow B. And we'll call the light blue C. And let's write each of these equations. Now, I purposely picked some lines that aren't quite as nice. The slope doesn't cross at a nice whole number here for A. And C, it doesn't cross the y-axis, so it's hard to find the y-intercept. We're going to have to do some work with that, but I'll guide you through it. So if you're taking notes, I'd make sure you pause the video, get this copied down, write down the graph, and then once you're done with that, follow along. Okay, so what we're going to do is for graph A, we're going to take a couple points. We've got this point over here is 1, 3. And let's find another one. How about this one? -2, 1. We've got 2 points on the line. 1, 3, and -2, 1. So if I'm given 2 points, I can find an equation using those 2 points. I'm going to start with the slope. The slope, we take y2 minus y1 divided by x2 minus x1. So my slope for A is going to be -2 over -3, which is the same as 2/3. So this is going to be my slope for A. And if you didn't want to do all that work, you could have just counted up to over 3. That would have been the much easier route to finding the slope, but just a good refresher there. And then what I'm going to do is do y minus y1 equals the slope times x minus x1. So this is point slope form of a line. We have the slope, we've got a couple points. We're going to plug that in and we'll have our equation. So y minus, and then I'm just going to pick one of the points. So I'll say y minus 3 equals the slope, which is 2/3. 2/3. And then x minus 1. All right. And then the one thing that we do need to do is we need to get it just to y equals. So there's a cheating method, like maybe not a cheating method. Actually, some mathematicians would say you're being lazy. Some would say you're just being smart. Smart way is we're just going to add 3 to both sides. and we get y equals 2/3 x minus 1, and then plus 3. And that will be our equation. If this bothers you and you're screaming, we got to distribute that 2/3, then distribute the 2/3. You can do that, but you do not have to. You do have to, however, get it just to y equals. You cannot leave it in point slope form, because when we write our piecewise function, it's not going to work out quite as nicely. Okay, that one was some work. Part B is going to be a lot less work. Part B is just a horizontal line. And so a horizontal line is whatever that value is for the y value. So it's just y equals 1. So we're done with that one. And then part C is going to take a little bit of work. C, I noticed that my slope is going to be over 1 down 3. So my slope is going to be -3. So m equals -3. And then I can write my equation. It's going to be y minus, and then let's see, this point where it starts is over 4 down 2. So y plus 2 equals the slope, -3, and then x minus 4. All right, and then if I get this set equal to y, I'm going to scroll down here. It is y equals, I'm going to subtract 2 from both sides, -3, and then x minus 4 in parentheses, minus 2. So I have my 3 pieces of my piecewise function. Now I can write my piecewise function with these 3 parts. All right, so let's do that. We're going to write our f of x equals, and then a bracket. It took me about 10 years to figure out how to write a bracket. And then we just write our 3 pieces of our piecewise function. So for the first piece that was orange on the graph, that's the y equals, and remember, we don't need y equals. The f of x replaces the y. So it's 2/3 x minus 1 plus 3. The next piece is just y equals 1, so we just put a 1 there. And then the next piece is -3 x minus 4 minus 2. All right. And then we're going to define where these graphs happen. So I'm going to do a semicolon for each piece. And if you notice, the orange graph stops at 1. So A crosses at 1. I got interrupted. I had to pause the video. So A crosses at, it stops at 1 when x equals 1. And so for A, we're going to, I'll just put everything in light blue. A happens when x is less than or equal to 1. Because at 1, right here on the graph, the orange graph is a closed circle and goes to the left. So I know it's less than or equal to 1. All right, I'm going to do some erasing here. And then from 1 to 4, the yellow graph is happening, that B graph. And so the way we write from 1 to 4 is we start with a 1, we end with a 4, put an X in the middle, and then we write a string. So we do less than, and then whichever one has the closed circle, you make sure it's less than or equal to. So since there's a closed circle here at 4, that's going to be the less than or equal to. So whenever you're trying to write a string from this number to that number, so like from 1 to 4, it's always going to look like this, where it's 1 is less than x is less than or equal to 4. Sometimes the less than or equal to and less than will be switched around. Okay, and then the bluish, light bluish colored graph goes from 4 on forever positive. And so that is x is greater than 4, and that's a close, excuse me, it's an open circle, and so it just goes x is greater than 4, not greater than or equal to. So just to summarize, what you got to do is you take the graph that's given. You can use point slope form of a line to write the equation, and then you get it set it equal to y. Or if it's just a horizontal line, it's just y equals that number. And then once you get that, you define where the graph exists. And that's what I did over here in light blue on the right after the semicolon. So for every piecewise function, sometimes, as you get more involved in math and things start getting a little bit harder, it won't be lines. It might be some, parabolas or even more complicated graphs. But for now, we're just going to talk about what if we have lines that are broken into sections like this? And so this is how you'd write a piecewise function for a graph like this.